In this final example, we'll see how the use of various forms of quadratic relations can help us answer some questions. So in this example, we have an engineer who's designing a front gate for a new school building or a front entrance, and it's going to be in the shape of a parabola. And here is the equation of that parabola, where h is the height of that door in meters and d is its distance horizontally across. Okay, I've also got it in meters too. The first thing says, how wide and tall is the arch? So if we can imagine sketching this archway such that it is centered about the y-axis, that might help us answer these questions a little bit easier. So how tall is it right here? Well, this height occurs at the maximum or at the vertex, right? Is there an easy way to find the vertex? Well, the nice thing about centering it about the y-axis is that the vertex is also the y-intercept. So we know that x is 0 here. The question is, what is y? Well, right here given to us is the parabola in standard form. It's just that it has inside of it a plus 0d that we didn't bother writing in, okay, because it was equal to 0. And we know that if d is going to be equal to 0 here, we can sub in a value of 0, and we're going to get this term disappearing as well. So the height of it must be 16 meters high. This is a really big front door if it's 16 meters high. It's pretty majestic. That was pretty great. How wide is it? Well, the width is going to be taking us from here to here. And again, we've got it centered about the y-axis, or the y-axis is the axis symmetry. So if we could find the distance from here to here and from here to here and put them together, we would therefore know how wide it is. So because these parts of the parabola are touching the ground, these are the roots. So is there a way that we could solve for the roots of this? Well, sure. Let's let h be equal to 0, right? There's no height there. 0 is equal to negative d squared plus 16. What would happen if we brought that negative d squared over to the other side to try and solve for it? Well, it would become positive. And the great thing then is, in order to solve for d, all we have to do is take the square root of both sides. Now, d is equal to 4, but let's also remember that there's another square root of 16. It can also be negative 4. And so, if we have a distance from the center to here of 4, and from the center to here of negative 4, our total distance must be the sum of those together, right? And imagine if you're walking from here to here, you're going to be walking 8 meters across. Okay. What range of values can d be? Okay, so in other words, are there any values of d that cannot be included in this parabola? Now, we're used to talking about the values that x can have for a parabola as being the set of real numbers. It can be anything. And that is true if we're talking about the parabola going on and on and on forever, 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 forever. But we are only building a section of this parabola, right? We're only building it from here to here. So we can't have any x values that are outside of negative 4 or outside of positive 4. So that means that all of our x values have to be in between those two extremes. It's allowed to be equal to negative 4 and equal to positive 4, but it can't be outside of that. And this is a really cool way to express that. All right, how many front doors could be created under the arch if each door was 2.5 meters wide? Well, 2.5 meters wide going across would mean that, if we had 2 of them, we would have, here's door number 1 and door number 2, we would have 5 meters across. And we go, yep, that would fit inside of there. What if we had 3 doors? Well, then we would have 2.5 times 3, which would be 7.5 meters. And you would go, well, yeah, that would fit because we can do 8. But would it? If we were to center this 7.5 so that it's equal on both sides, what's going to happen is that the doors are going to get up so high and then they're going to stop, right? And if it's 8 meters across, but we're going to go 7.5, centering it, that must mean that there's a little bit here and a little bit here that results in this little corner space here and here, you see. How big are each of those spots? Well, I've only got half a meter left in total, and half of that would mean it has to be 0.25. And 0.25 here as well. So can we fit 3 doors across? Well, what would the value of x be right here? Well, it's going to be half of 7.5, right? Which would be 3.75. Let's sub it into the equation and see how high those doors would be in that case. Okay, so h is equal to negative, let's let d be 3.75 squared plus 16. We have to do exponents first before we do the negative on the outside. So 3.75 squared comes out to 14 point, about 1. I'm going to round it up. It's 0.6, okay, plus 16. So if I do 16 minus 14.1, that means that each door would end up being 1.9 meters high. Okay, now I don't know how tall each of you are. It varies. I'm not 1.9 meters tall or 190 centimeters. You know, I'm around 167-ish, right? The people who are taller than 190 centimeters would have to duck their head under the door if we were to split this up into 3 even doors. And I'm being very approximate here when I estimate thirds. So how many doors could you fit across? Technically, you can fit 3. They're only 190 centimeters tall. That'll work for a lot of the population, but not all of it. You're probably better off having 2 doors inside that arch instead. Maybe 1 to the left and 1 to the right, and they'll be able to be big and majestic and be able to open up, and everyone will fit inside. All right, this is the end of lesson 6.3. If you have any questions, feel free to contact me.